Hey guys, welcome to day 18, and today we are going to be talking about queues and stacks. And so we are going to be adding two more data structures into our toolbox of data structures. And so far we've done arrays, dictionaries, and linked lists, and these have all been data structures because they are containers, meaning they can hold many different objects. They can hold a bunch of ints, they can hold a bunch of strings, characters, you name it, they can hold it for you in their little containers. And so now we are going to have two more, queues and stacks. This is going to be a little bit more theoretical than the last video, but stick with me because this is super important and will come in handy when you're trying to make these really big, huge programs and you want data structures to hold your data. So the first big data structure we are going to be talking about today is a queue, and it acts just like you think it would. We describe the way it operates, the way it works by FIFO, and it's an acronym, and basically what it means is first in, first out, FIFO. And so think about when you're going to Disneyland or to the movie theaters, you always have to wait in a line. Very annoying. First for the tickets, for the popcorn, for the candy, whatever you want. It doesn't matter what you're waiting for. You always, you gotta stick to that line. There's no cutting at Disneyland. They kick you out of the line. The first person that got in line, or the person that's been waiting the longest, is always the first to get their ticket, popcorn, or whatever. So that's the way our queue works. The first item that goes inside of our queue, the first person that gets in line is the first item to get out of the queue. FIFO, first in, first out. First person in, first person out. So we can say we have an empty queue, which is just kind of this empty data structure, and we can enqueue items into the queue. So we could put a 5 in the queue, a 3 in the queue, and a 2 in the queue. If we want to remove something from the queue, we do something called dequeuing. And so we would have to dequeue the 5 because it was the first thing inside of the queue. Then we could dequeue the 3, and then we could dequeue the 2. You can't just, if you have 5, 3, 2 inside of your queue, you can't just dequeue the 2 without dequeuing the 5 and the 3 first, because it operates by first in, first out. Bringing this back to real life, it means we can't just take the middle person in the line and service them before we can serve, the first person that got in the line. Make sense? So we have to dequeue the first element that came in before we can dequeue anything else. There are also other things that we can do. We can check the size of the queue, see if it's empty, and even peek to see what the first element is. So if we have our 5, 3, 2, again in that order, we can peek and see 5 is the first in line, or it's they're the next person to be serviced. And we can actually implement this inside of Java. You are going to create another data structure for people that didn't like this the first time or doing it again. Sorry. I remember this was really frustrating for me when I was doing my beginner computer science classes, but it is so necessary because you need to know later on, when you're working with these data structures, it's very nice to know exactly how they work and what's going to happen and how you can use them if you've actually made them yourself. So let's do it. Let's make data structures. Okay. So we are going to open NetBeans, and there we go. It's going to load per usual. And we are going to be implementing a queue with a linked list. And so inside of our program, we're going to have a linked list as a property, and then we're going to create a constructor, an isEmpty method, a size method, an enqueue, a dequeue method, so we can actually put stuff in our queue, and then a peek method to see, okay, what's if I dequeue, what is going to be the item? And you can do that without dequeuing. You can just peek and see, okay, who's been waiting the longest, who was the first person in for this series of people. So now that it is open, you know what we're going to do. File, new project, and we are just going to go next. Put it on the desktop, and we are going to call this QE because it's a QE. Like I was saying, we have this queue, our QE, that's going to be our queue. And the first thing we're going to do is actually create a property, and the property is going to be a linked list. And so we are going to use Java's linked list that's built into the system, just because our linked list, the way we made it, it wasn't very well done because we didn't, go through and do a bunch of testing, whereas Java's is very well tested. So usually if you're making a program and there's something already available to you, within Java, you should use it because, they know what they're doing. But yeah, you get what I mean. If there's a function that's available in the system, you should use it versus making your own, unless there's something you really don't like about the one that Java or some other person. If you don't like, their library that they're giving you, of course, create your own. So yeah, we are going to create a linked list, and so we will do linked list, and we will call this linked list a queue, and we will make this equal a new linked list, open close parentheses, and the semicolon. Great. And we need to import things, import, this Java thing, Java util, it's our friend, and there we go. So now we have this queue. Now there's a bunch of things that we have to create method-wise. Like, how is this linked list gonna act like a queue? Well, when we created our linked list initially, basically you could traverse through the linked list, and when you were removing something, you could remove it from any index. And so with a queue, it's first in, first out. And so when we remove something, we're going to remove it from the head of the list, and when we enqueue, we add something new, we're going to add it to the back of the linked list. And then we're going to only make those two types of operations, the enqueue and dequeue, available to whoever's using, QE, so that they don't mess anything up and our class acts like a queue. I've done a lot of talking, so I'm going to just code. Yeah, let's code some more. Okay, so we're going to do a public QE, and this is our constructor. And we're just going to do an open close parentheses, and we're not going to let you put anything inside of the queue initially. So yeah, sorry. We are just going to initialize our linked list, and so we're just going to do queue equals new linked list. And that means we don't have to do it up here. You could do it up there and just do nothing in your constructor, but I don't know. I like this better. Preference. Okay, so we have our constructor. This is how we make queues. And so we'll just say making a queue instance. This is how you make a queue instance, how you make your singular queue. Now we can make a method called isEmpty that will check if the queue is empty. And so our queue here is represented by a linked list. And so if we do public is empty, open close parentheses, open close curly bracket, and we are actually going to have this return a Boolean, remembering to code correctly. And in our isEmpty, we just have to check if our linked list, which represents the queue, is empty. So we'll do queue dot, and we get all of these lovely methods, as you can see. And it should have an isEmpty. We can just type in is, and boom, there it is. We want to just return, if the linked list is empty, that means our queue is empty. So awesome. Now another thing, we'll add a comment. Checking, or we'll just say, is our queue empty? And then we'll do another method that's public int size, and this will just return the size of our queue. So we'll do return queue. Oh my god, I cannot spell. Okay, and look, boom, it knows I'm returning an int, and so it's giving me all of these things that return an int first, and then it has this line here. Isn't that nice? Isn't that great? It's fantastic. So we're just returning, the linked list is representing our queue, and we are returning the size. So what is the size of our queue? Awesome. Next method. These are the more interesting methods. And so we are going to enqueue something. So we're going to do public void enqueue, open close parentheses, and inside it's going to take an int in. There we go. And it doesn't have to take an int. We could make our queues generic, which is something you'll learn about very, very soon. I feel like it's in the next couple videos, very close. Yeah, that'll be something you learn about later. Basically, generics will allow you to not say this is int. You can just say it's type D or type E or something, and it can be any type you want that has, the right qualifications that you say this generic has. But we'll get that to later, so yeah. Okay, so int. We're just going to say everything you enqueue is an int, and you could make it a string if you wanted to. Yeah, character, And so oh look, El Capitan, very excited. Okay, we'll do that later. So we are going to enqueue this thing, and so what does that even mean? Well, it means we're going to add whatever this int is to the back of our linked list. And so how are we going to do this? We're going to do queue, because that is what represents our queue, and we'll check it out here. And we will scroll down. Oh, look, add last. Guess what? That's what we want to do. We want to add it to the end of our linked list, and so that's what add last is going to do. We're done, so we're going to say enqueuing an item, and then we are also going to give the functionality for something to be dequeued, to remove something from the queue. So we're going to have public int, because everything inside of our queue is going to be an int, because the only thing you can enqueue is an int. You get this. Okay, so we're going to dequeue, and basically dequeue is also going to return the element that you're removing. And so if you wanted to traverse through this queue, you would like dequeue an element, and then you would have access to that element. And so we will say dequeuing. Gosh, I hope I spell, is that queue, dequeue? Yeah, that works. Okay, dequeuing an item. And then we're going to say return this queue dot, and then we type in remove. We have this remove at index, perfect. And so we can remove the first thing in the list because it's first in, first out. So when we enqueue, we add to the end, and then once that thing gets to the front, we dequeue it at the front. So we want to dequeue the first thing. Now we're going to get an error, and that is because object cannot be converted to int, and that is because of generics that are in queue, again, a later topic. And so we basically just have to cast this to an int because we have to specify, what it is. And the reason this is a really good example of casting, because we know no matter what we enqueue, it's going to be an int. And so unless we construct an object like in our constructor here, unless we enqueue something like inside of here that is not an int, then everything inside the queue is going to be an int, and so we are safely able to cast this, and we know no matter what we're removing, it has to be an integer. And the last thing is peek at the first item, and we can do this by just saying public int peek open close parentheses, open close curly bracket, and again, we know everything inside of our queue is going to be an int, so this is going to be okay, and then we're going to do queue dot get, and then we can just do the thing at index 0 here. And we'll have to return it, and we'll have to cast because this, again, returns an object, and we want it to return an int. And we're good with this because everything inside of our queue is an int. And so, yeah, this will peek and see the first item, but it will not remove it from the list like dequeue would. And so understanding the difference between dequeue and peek, super important. So we just made a queue inside of Java using linked list. Amazing, awesome. And so we are actually going to do stuff with our queue. So we could do QE here, and we could call our queue QEQ. Yeah. All right, our queue QE, and we are just going to say new QE, open close parentheses, and there we go. We have this new queue QE. There he is. And let's not call, this is going to kill me. We are going to call this number queue, just so we can like set our thing straight. And so we are going to do number queue dot enqueue, and we'll enqueue like a 5, and we'll number queue dot enqueue like a 7, and then number dot queue dot enqueue a 6, and then we'll do a system.out.println and print out like what we're dequeuing. So if we do first out, and then we can do plus number queue dot dequeue. Yeah, there we go. So we can do first out. This, we will copy this, and we will say second out. So like what was the second thing that got out, and then we'll do third out. And so now we will run this, save, run it, see what happens. And notice we enqueued our 5, we enqueued our 7, and then we enqueued our 6. And when we dequeued, the first thing out was a 5, the next a 7, and then the third a 6. Now what if we did a peek here? Like what if we do peek at second item, and we can change this to peek and save, run it here. And it will say like the first out was 5, the next item that we're going to remove is the 7, second out is 7, and then the third out was a 6. And so we can like test all of these and see like what they do, but I'm not going to do that right now. So if you want, have fun with that. But I'm going to show you, you can also do this with any type of thing. And so we can actually just comment this out for now. And we are going to create a different type of queue that's not a number queue, and it's going to be a string queue. And so we will have to change our methods, which is going to be so annoying, but we are going to say that our queue is only going to hold strings. And so we have to change all of this to strings. And I hope you understand how annoying this is, because when we do generics, it's going to be fantastic. It's going to be great, and you'll be able to convert this, and so it accepts anything that you decide it accepts. And so sometimes they can implement an interface. I should just stop talking before we just get into deeper things. And so we should be good. We can enqueue a string, we can dequeue a string, and we can peek at a string. And so Now we will do another QE, and this will be a string Q equals new QE. And we are going to do string Q dot enqueue high, and then we're going to string Q dot enqueue there. And then we are going to do the same thing, system.out.println, and this time we'll just say string Q. And we'll actually have this print on the same line, so that'll be great. And so we'll just do print, and then we'll do a little plus and a space, and then we can do this again and do that. And we need to say .dq so we know that we are removing stuff. And this dq will return the string that we dq, and we'll put a little period there. Here we go. We'll run it, see if it works. Hi there. So it worked. Awesome. And notice how I put in hi and then there. You understand queues. This is great. I'm feeling you understand it. So and that was our first data structure. First in, first out. You had peak, you had enqueue, you had dequeue, you were messing with numbers. It was great. It was like standing in a line at Disney. Now we are going to move on to stacks. Stacks can be built from linked lists as well, but they operate in a different form. They do LIFO, last in, first out. And so I hope that's how you say it, or else I'm going to sound not so smart. But LIFO, it's last in, first out. And so here, the last thing you put in is going to be the first thing that comes out. And so think about a stack of cards. Say you have your stack of cards and you draw the Queen of Hearts and then you place it down like in a different stack. And then you draw another card and you get the King of Hearts. And so you put that like on top of the Queen. So then you have the Queen and then the King on top. And then you draw another card, you get the Ace of Clubs. And then you put that guy, you put him right on top of the King. And so to get back this Queen of Hearts that we had originally, we have to first pop or remove our Ace of Clubs, take it out of there, and then pop again to remove the King of Hearts. And then we can peek like we did with the Q and look to see, oh, once we've removed our ace and our king, we peek and we see the queen, and then we can pop, our queen as well. And so you can either push things onto a stack, that's how you add things, or you can pop and remove things from the stack. Get it? So your challenge at the end of this will be to implement the stack with linked lists like we did with the QE, but it's going to be very similar to the Q, but it is last in, first out because it's a stack and everything builds on top of each other versus being in a cohesive line like a Q. However, just like linked lists, queues and stacks are already built into our Java. And so yes, we did implement QE here, but it's actually implemented inside of Java as well. And so we can just have our QE be here. We actually will probably comment this guy out. And so we are going to just mess with the idea of stacks. The idea you can peek, you can push, and you can pop things. And so push, you add, pop, you remove. And so how do we do this? We do stack, and we'll just call this stacky. And we will call this a new stack, open close parentheses. There we go. And it's going to be mad, and we're going to add this import. And it's good programming practice to have a little open caret here, string, close the caret, and then we can do a little open close over here. It's good practice to do this because now we know, okay, only strings can be in the stack. And usually when you're working with a data structure like a stack, a queue, a linked list, an array, a dictionary, throwing it all at you at once. Basically when you're working with one of these data structures, you are going to want one data type in the list. And usually if something else comes in, it's not good. And so it keeps it very organized, like, okay, my strings are going to be in the stack, and that's it. And so here's stacky. If we go stacky dot, we have all of these amazing methods. Like Java libraries are great. You can just pull things out of here. It's fantastic. And so notice we have empty here. Like we can see if it's empty. We can peek, we can pop, we can push, like I was saying before. So we are going to push a string, and we will do there. So we're going to do the opposite of what we did with our queue, and then we'll do stacky dot push high. So now when I pop, it's going to show me high first, and then I pop again, it's going to show me there because it's like a stack of cards. And so we put down the there, then we put down the high. It's kind of like Cards Against Humanity, when you have like the double, the two, when you have to do like the choose two or create a haiku or something like that. That's also something you can think of here. And so we are going to do system.out.println stacky.pop. and then we will actually do a plus and then add a little space here, so it's nicely formatted for us. And we're going to do system.out.println again, stacky.pop plus, here we go, and we'll put a nice little exclamation point at the end. And so if we run it now, it's going to go, hi, there. And it did it a little bit different because we had println instead of print. And so if I change this here and we save, then it's going to print on the same line, hi there. Notice if I switch this, if I switch these two lines of code, if I push the hi first, it's going to say there hi, because there is on the top of the stack when I pop, and so there hi, it happens. And so I'm going to switch this back so we can have it all good for us. And of course there's other methods you can use. You can do stacky.size, and we can print out the size if we want. So system.out.println, println size. And there's a bunch of different methods that we can use to like find stuff out. And we could actually do a peek here. So if we do peek, and we did println here again, and then we did stacky dot, here we go, dot peek, open close parentheses, save, run it. There was at the top. I added the exclamation point, which is why it's not inside of the peek, and then the size is 0 once we pop everything. So we can also do this with queues. I'm not going to go super in depth with it with the queues, but you can do queue, again, string queue equals new queue, and then open close parentheses. Here you go. It's going to error. You have to import things, import this data structure, and it works. You'll have queue dot, you'll have all these methods again. So that's how you would mess with queue stuff, and queues are actually abstract, so you couldn't exactly do this. You'd have to create another thing that extends queue and then implements its abstract methods, because if you go to the error here, queue is abstract. And you would know this by looking at the documentation. And so if we actually go to Google, we can look at the documentation. If we just type in queue Java, and boom, the first thing that comes up, the documentation. And documentation just says like, okay, how do we do things? Like how do we use these methods that are given to us in Java? Like there's an add, there's a remove, blah, blah, blah. I actually clicked one of them, whoops. If you click like add here, it'll tell you, okay, this is what the signature of the method is. This is what it does. This is what it's specified. Here, like what it takes, what are the parameters, and here it's it's any element, and then what it returns based on the input. And then exceptions down here that may be thrown if there's an error, like a null pointer, if you're trying to add something that's null or something like that. And actually here are all of the implemented like things inside of Java that you can use. A linked list is actually a queue. It has the queue interface, meaning it adds and removes interfaces we'll talk about later, but basically it's abstract, so you need to implement methods. I said that queue was an abstract class earlier. It is not. It is really an interface, and we will talk about the difference between interfaces and abstract classes later, but just know that you can't instantiate an interface or an abstract class, and we will talk about that later. And so this is it for now. If we go back, we can actually also search for stacks, Java. Here we go. We can click on this. And we have a whole list of things we can use here and what they do, what it returns, what are the signatures, how do you call it, stuff like that. Because not all IDEs, like our NetBeans, will allow you to do like stacky dots, and it gives you, like some of them don't give you all of these methods. And yeah, you have to be smarter to use those because you have to remember things or you have to look up things constantly. And so what did we learn today? We learned 2 different data structures. You have queues where you can dequeue and enqueue things. It goes by FIFO, first in, first out. And so there's no cutting in the lines. The first person inside of the line is the first person to be serviced. Then we had stacks, which were push-pop. You push things onto the stack, you pop things off the stack. It was done by LIFO, which means last in, first out. And so the last thing that we plopped onto the stack is the first thing that we take off. They both had peaks, so you could see, okay, what is the next thing I'm going to either pop or dequeue? And then they had is empty in size as well. And it's important to notice that the only way to traverse a stack or a queue is to pop or dequeue things. And so if we traverse through an entire stack or queue, without saving what we removed or what we, popped off, what we dequeued, then the stack or queue will be empty at the end. And so we won't have access to that stuff anymore. Like when I dequeued, at the end, like our queue was empty and we no longer had access to those items. So either when you do this, you need to either save what you're popping or dequeuing, or you need to be okay with losing that data. Note, this is not the case for linked lists. Even though that we implemented a queue with our linked list, we didn't use all the capabilities of a linked list. In a linked list, you can traverse through the list without removing anything, and that's not the case for a queue or stack. And so we, as programmers, limit the capabilities of a queue or a stack because we want it to act in a certain way. And that has consequences, meaning that you can't traverse it without removing things. And we also looked at documentation for the first time. And so I'm going to be doing a super in-depth video about how to use documentation. I kind of just like scrolled over it here, but documentation is really cool because you can look all the stuff you've been using in Java and see like what you should use it for, like example code, as well as see, okay, what does this method do? What does isEmpty do? Even though that one's really easy, there might be some complicated word method that you want to know, like what it takes and then what it does and maybe any side effects it has on the program. Like remove, yeah, it returns a certain item, but it also takes it away from the list versus just like peeking at what is the next thing that we're going to remove. Another important resource I didn't show you until right now is Stack Overflow. So if you're having problems with anything in code, Stack Overflow is your saver because check it out. All these people have problems. And all these people have their problems answered. And so this is an hour ago. Look at all of the stuff that has been submitted since an hour. A lot of people have programs with code, and boom, we have search. And almost every problem that you search, like if we go back, we say null pointer, meaning we tried to access something and nothing was there. Array, you're gonna get some Stack Overflow, boom, first one. And so super helpful resource if you're having problems. So that's it for today. I hope you've been enjoying these videos and that you learned something today. I really like doing these videos, and I hope you're finding something cool about computer science that you like building things, you like making the programs, or you like the abstract concepts, like what is recursion, what is a stack, these abstract things, or you just like, making your Mad Lib that we did a while back, or even your hot chocolate. I hope you've been enjoying these and you've been learning new stuff. And so that's it for this video. The HackerRank challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.